Good evening to all of you. I hope my voice is clear to all of you, my dear. Good evening to all of you. Please let me know whether my voice is clear to all of you or not. Please let me know whether my voice is clear to all of you or not. Voice, no voice. Oh, sorry. Is it clear now? Is it clear now? That is the reason I always ask, na? Is it my voice is clear to you? All okay? So we were discussing about specific energy. Now this small diagram I am drawing for you. This is our datum line. This is the channel bottom. This is the hydraulic rent line. And this is the HTEL line. So this distance we call it as Z. This we call as depth. We are indicating with Y. And this we are calling at V squared upon 2G velocity depth. So if someone will write total energy, what you will write? Z plus Y plus V squared upon 2G. This is the total energy. But if you write the specific energy now, you can first write the definition of this. So specific energy is the total energy with respect to channel bottom as datum. Specific energy, total energy with respect to channel bottom as datum. That means this datum you are taking at this point. That means this channel bottom itself you are taking as datum. Now you guys can tell me, if channel bottom, this white line itself is taken as a datum, out of these three quantity, which quantity will not be there, or which quantity value will be 0? If you are taking channel bottom as datum itself, this is the datum na. But if you are taking channel bottom as datum itself, which quantity will be 0? It's clear na? Z will not be there. Z will not be there. So if Z will not be there, then your specific energy formula will be E will be equal to Y plus V squared upon 2G. Anybody having any problem, they can tell me. Anybody having any problem, they can tell me. Is it clear? Note it down quickly. Okay. Now in this, three cases are possible. Let me draw three cases for you. Then I will explain this to you. For a specific energy, three cases you need to remember always. First case, channel bottom is completely horizontal. Second case, third case, okay. This section is 1 1. This is 2 2. So this case is nothing but the hump case, fall case, channel bottom fall in this case, so fall case, and horizontal, no change. No change in channel bottom. No change in channel bottom. So if we don't have any change in channel bottom, understand this part. If you don't have any change in channel bottom at section 1 and section 2 for a given discharge, E1 will be equal to E2. For a given discharge, that is very important. For a given discharge. Okay. Now, second section in hump. Here, this is the delta Z, the rise which you have given. So here your E1 will be equal to E2 plus delta Z. E1 will be equal to E2 plus delta Z. Okay, so here in this case, as you can see here, E1 will be more compared to E2. Third case, fall case. So here if you see, E2 will be equal to E1 plus delta Z. E1 plus delta Z. This is a delta Z rise. So delta Z fall basically. So here E2 is more than E1. E2 is more than E1. So as you can see here, as channel bottom is changing, then only the specific energy is changing. Otherwise, it is same only. At two different sections for a given discharge, specific energy is same only. Until unless you are not changing the channel bottom. Until unless your channel bottom is horizontal. Until unless your channel bottom is horizontal. Is it clear? Note down quickly. Okay. The next one is specific energy diagram. Specific energy diagram. Now understand this part. It is very important for you to understand this curve actually. This axis we have depth and this axis we have specific energy. Understand? This line we call as potential energy line. Why we call it a potential energy line? If you take any section, for example, any point if you take, I'm showing with a different color. Any point if you take, you will find your specific energy is equal to the depth, because this line is completely 45-degree. So any point if you take on this line, you will find your specific energy is directly equal to the depth itself. That is the reason we are calling it a potential energy line. I hope you guys have understood it. I hope you guys have understood it. Now, if you want to draw the specific energy line, it looks like this. It look like this. It look like this. Here you will find the minimum specific energy. And you know, for minimum specific energy, the depth will be YC. The depth will be YC. Critical depth. Okay. This thing is clear. So in this curve, two limbs are there, lower limb, upper limb. Upper limb is more, the upper limb having depth more than YC. So it's a basically subcritical zone. So here I am writing it as subcritical zone. Lower limb depth is lesser than critical value. So here I am writing supercritical zone. Supercritical zone. Okay. Now some of you guys are having, sir, how we can see this? This curve is making asymptote with this potential energy line. That also you can do it with this way. E equal to y plus v squared upon 2g. So if you write E equal to y, if you are taking common, 1 plus v squared upon 2gy. So if you are taking y tends to infinity, if you are taking y tends to infinity, what will happen here? E will be tends to y. So in that case, if your y tends to infinity, your E tends to y. Y means this potential energy line. So where it will happen at the if infinity, and that's what the meaning of this asymptote line, that it tries to meet, but when this line will meet, it will meet at infinity. So this specific energy line make asymptote with potential energy line. Few things which you need to understand it, that every specific energy curve is drawn. This point, if you want, you can note it down. Every specific energy curve is drawn for a given discharge. If you are changing the discharge, a different specific energy will be there. So for example, in a river, so many specific energy can be there, can be drawn for different discharge. That can be possible. For example, if you are drawing specific energy curve in the right direction, keep on drawing. In that case, what I can say, for example, here if I am drawing something like this, so this specific energy curve will have more discharge compared to this. How we can say this? Because this specific energy curve, the minimum specific energy is more than the previous specific energy curve. So this yellow specific energy curve is having more minimum specific energy. You can see here, if you plot, this specific energy will come here, and that is the minimum specific energy for this yellow part, for this yellow specific curve. So here you can say this yellow curve or yellow specific energy curve is having more discharge. So if you increase the discharge and all, different specific energy will come, and it will come in the right side. If any specific energy is coming in the left side of this green line or left side of this green curve, that means that specific energy is drawn for a lower discharge value. I hope you got this. Basic points are there, but these points are very important for you to remember. Another thing is like, one is this one. Another is like, if y tends to 0, in that case, flow can't occur. If your depth is not there, then what is the meaning of flow? Flow can't occur. Is it clear? Flow can't occur. Note down these things. Okay. Now here only, if you take any other point other than this leftmost point, this is the leftmost point in this curve. If you take any other point, you will find you are having two depths. You are having two depths for same specific energy. For a same specific energy, we are having two depths, y1 and y2. y1 and y2. And these y1 and y2 we call as alternate depth. These y1 and y2 we call as alternate depth. What are the alternate depths? Depths which are having same specific energy. Depths. Oi. What happens? Depths having same specific energy. Depth having same specific energy. This point you need to understand it. This point you need to understand it. Okay. Now here another thing will come. Another small topic will come that we call as relation between Proud number and alternate depth. So I will be showing you for rectangular section. You all can find out for triangular as well as other section also. So basically what I'm trying to do, I'm trying to make a relation between proud number and alternate depths. So if y1 and y2 are alternate depth, you know that y1 plus v1 squared upon 2g specific energy will be same. This all of you guys are knowing. So if I will be taking like this, I'm taking y1 as common. It will be 1 plus v1 squared upon 2g y1. Here I'm taking y2 as common. 1 plus v2 squared upon 2g y2. Now if you focus, my dear, general formula for Froude number is what? I have already given you v upon root under g into d. You know that for rectangular section, the hydraulic mean depth d is nothing but v upon root under g into y. So basically d is equal to y. So Froude fr squared, if I am writing, it will be v squared upon gy. Anyone having any doubt? No, sir. So v squared upon gy. Can I write in place of this? Can I write fr? Yes, you all can write, sir. 1 plus fr1 squared divided by 2. Very good. y2 1 plus not v2 fr2 squared divided by 2. So this is that. This is the final thing, that y1 1 plus fr1 squared divided by 2 is equal to y2 1 plus fr2 squared by 2. I hope it is clear to all of you. I hope it is clear to all of you. Like this relation I have made for rectangular section. This is completely for rectangular section. You can find out this for triangular also. Only the Froude number formula will change. This I have made it for rectangular section. Is it copied? Can you guys make a relation? See, we have made a relation between Froude number and alternate depths. So can you guys make a relation between non-alternate depths and Froude number? While writing, you can think of this. While writing this, you can think of that. How to make a relation between Froude number and non-alternate depth. So here you have taken alternate depth. Here specific energy are same for y1 and y2. But if it is a non-alternate depth, what you can do? Is it copied? Okay. Now let's make a relation between proud number and non-alternate depth. See, this relation you can find out very simple. Again, I'm using rectangular only to make this relation. Rectangular section example I'm using. So fr equal to v upon root under g into y. So fr equal to, I can write in place of v, I can write, or fr square will be v square upon g into y. Fr square, in place of v square I'm writing q square divided by g into y into area square. So fr square q square g into b square y cube. I don't think so anybody will have any problem in writing this. So as you can see here, q is constant, g is constant, b is constant. So what I can get it here from this, that fr square is directly proportional to 1 upon, like basically inversely proportional to y cube. So I can write a relation fr1 square divided by fr2 square is equal to y2 cube divided by y1 cube. This relation I can make. And this is for non-alternate depth. This relation is for non-alternate depth. I have not taken anything like same specific energy and all. Nothing I have taken. Na? So this relation is for non-alternate depth. This relation is for non-alternate depth. Copy it fast. Next one is discharge diagram. Discharge diagram. Next one is discharge diagram. Okay. How it look like? This is the Q maximum. In x-axis we have small q. Small q is actually capital Q by B, discharge per unit width, and this is depth. So at critical depth you are getting maximum discharge. Here also upper limb will be there, lower limb will be there. So upper limb will be nothing but for subcritical, because depth is more than the critical depth, and this is for the supercritical. Rest thing is same, nothing to discuss about. But always remember, a given discharge curve, here I am writing, every discharge curve is drawn for a given specific energy. Every discharge curve is drawn for a given specific energy. हर एक discharge curve आपको एक particular specific energy के लिए draw किया जाता है. Every discharge curve is drawn for a given specific energy. For a given specific energy. Okay. Now what happens, my dear? Few phenomenon like hydraulic jump and all, where losses are very high, in those situations, energy principle, that means the Bernoulli principle, that specific energy principle, will not be able to handle these large losses. Like you can handle small losses with the energy principle, but large losses, there we need, like in FM also, in fluid mechanics also, to deal with the impact of jet and all, we use momentum equation. So that means whenever the high losses are there, we need to use Newton-Baba, we need to call Newton-Baba, and Newton-Baba, that means we need to use momentum equation. So we need to, here also, we are having some situation like hydraulic jump, surge and all. Here we need to use momentum equation. So momentum equation is introduced, and to introduce that momentum equation, we have given a new term that we call as specific force. What do you mean by specific force? Specific force is the force per unit weight of water of a channel. Per unit weight of water of a channel. So if you write the specific force formula, it is like, it is a Q squared upon GA plus A into Z bar. Now for example, I am taking example of a rectangular section. Okay. I am taking example of a rectangular section. So if this is the free surface we have, so from the center of gravity to the free surface distance, this something we call as Z bar. Resting area is the area of cross section. Q already you know. So this F is basically combination of two part, momentum flux as well as hydrostatic flux. So basically it's a combination of two forces. If you see this part, this is the first part, this is the second part. Look at how the first part comes. You know the hydrostatic force formula. One force will be always hydrostatic force, so rho g A into Z bar, rho g A into Z bar. Now per unit weight, so specific weight I am dividing it, so this becomes A into Z bar. First part is over. Look at the second part. Look at the second part. Now you all guys are knowing one formula, impact of jet formula. If you have not studied, you will study definitely in impact of jet. Rho a v square. That is a force formula because of impact of jet. Rho a v square. This formula I can write in different way. Rho q into v. Area into velocity I have written as q. Now here also I need to do same thing, divided by rho g, specific weight. Rho and rho will get cancel out. This will be q into v. In place of v again I am writing q square. In place of v I am writing q by a. So it will be ga. So these two part, from where it comes, I think it's clear to all of you. Q square upon g is basically the momentum flux per unit weight of the water, per unit volume. Okay, this thing is clear. So this is nothing but the, if you want you can write down also, it is momentum flux per unit weight per unit volume. Momentum flux per unit weight per unit volume. Per unit weight per unit volume. Here, this is hydrostatic force per unit weight per unit volume. Kindly note it down. Why this specific force concept introduced? Because this concept we can use it to deal with the large losses which generally occur in hydraulic jump and all. That large losses we are not able to deal with the inertia principle. That is the reason we introduce specific force principle, and in that specific force principle basically we have introduced momentum equation principle. So specific force curve is also there that I'm drawing for you guys. Here also you will find that at a critical depth you are having minimum specific energy, minimum specific force, and here also if you go anywhere in the rightmost part, for any specific force you will have two depths, y1 and y2. Here kindly note it down, y1 and y2 are conjugate depth. Sometimes we also call it as sequent depth. So these depth, that means same specific force. If two depths are having same specific force, we can call it as no. if two depth we are calling it as conjugate depth or sequent depth, that means for these depth specific forces are same. Specific forces are same. I hope it is clear. Okay, so if these concept you have understood, then we can solve some problem related to this. So this is the first problem. Solve it quickly. So in this question, 1 meter wide rectangular channel. So kindly to first of all write down all the given data. B is 1 meter. It's a rectangular channel. Discharge. So capital Q is 2 meter cube per second. Specific energy is diagram prepared for the channel. It is observed that in this diagram, the corresponding to a particular specific energy, the subcritical depth is twice the supercritical depth. So let us say y1 is 2 times of y2. So y2 is the supercritical depth and y1 is the subcritical depth. The subcritical depth is equal to, that's what they're asking. Okay, look at my dear. If it is a alternate depth, so in that case specific energy will be same. So y1 plus v1 squared upon 2g is equal to y2 plus v2 squared upon 2g without any doubt. Now if you see here, y1 plus in place of v1 square, I can write q square upon b. Anyway it's 1 only, so I'm writing y1 square simply equal to y2 plus q square divided by 2g into y2 square. I think that is clear to all of you. Now in place of these things, whatever we can write, just write it down. Like y1, in place of y1 I can write 2y2 plus 2q square. 2g in place of y1 I can write 4y2 square y2 plus 2q square g y2 square. Okay. Now again things which we can cancel out. y2 is equal to q squared upon 2g. In bracket we have q square upon 2g, with that y2 is y2 square also there na. So 1 minus 1 by 4. Is it clear now? Okay. So this will be y2 cube q square. Q square we have 2. So 4 divided by 2 into 9.81. This is 3 by 4. Any doubt? Any queries still here? No. Okay. So 4 and 4 will get cancelled out. You are having y2 is equal to 3 divided by 2 into 9.81 to the power 1 by 3. Tell me the value of y2. (0.534). But here they are asking subcritical flow. So we are interested in y1 basically. So into 2 we need to do 1.069. So 1.07 basically. Okay. Up to 2 decimal only they are asking. So 1.07. Is it crystal clear to all of you? Kindly note it down carefully. Take the next question. Simple question. 15-meter wide, normal depth 0.8 meter. Discharge carries 10 Q is given to you. What is the alternate depth that they are asking you? See, simple thing is that if it is the alternate depth, in that case Q square, or you can write y1 plus v1 square upon 2g is equal to y2 plus v2 square upon 2g. For first case, we have normal depth 0.8, q square upon, so q we have 10, so 10 square 100 divide by 2 into g, we need to take 9.81 na? Into area 15 into 0.8. Okay, equal to y2 we don't know, that we need to find out actually. This will be again 100 divide by 2 into 9.81 into 15 into y2 whole square. So in this equation only y2 is unknown to you, find out quickly. In this equation only y2 is unknown to you, find out quickly. Calculation will be a little bit lengthy, but you have to do it. This is 0.8353 is equal to y2 plus 0.022 divided by y2 square. Okay. So 0.8353 equal to y2, basically y2 squared, you can write it here. This will be y2 cube plus 0.22. The equation becomes y2 cube minus 0.8353 y2 square plus 0.22 equal to 0. Let us put this in equation. So we are getting three value. First one is 0.80. Second one is 0.18. Next is minus 0.194. So anyway, minus is not possible. We have to select between these two values. Already one value we have. Now to select these value, we need to find out critical depth. So what is the formula for critical depth? For triangular section, for a rectangular section, it is small q squared upon g to the power 1 by 3. So 10 by 15 whole square divided by 9.81 to the power 1 by 3. Let us find out this. This is YC and that we are getting as 0.3564. So one depth is already given to you, that is 0.8. So if one depth is above critical depth, so another depth will be definitely below critical depth. So in that case, your right answer will be 0.8. This is the right answer. So final answer for Y2 will be 0.18 meter. Clear? So this is the important thing which we need to understand it. Until unless you are not finding the three value, you will be getting a wrong answer also. And you need to check your answer with the critical depth, whether you are getting a value less than critical depth or more than critical depth, that you need to check and all. And then finally you need to give your answer as a right answer. I hope it is clear to all of you. So in tomorrow class, I will be discussing a new topic, that is a critical flow analysis. That I will be discussing. Complete discussion will be there for the critical flow analysis. Even numerical of the critical flow, like numerical related to that critical flow analysis. That also I will be discussed tomorrow only. So I want all of you guys to be present live on that case. Thank you everyone. We'll meet tomorrow. Same timing, 8 PM to 9:30. Till then, tata, bye bye. Take care.